Okay, well, sorry about the interruption. It was time for a new video anyway, but yeah, I kind of destroyed my garbage disposal last night, so I had to redo it. Okay, so let's get back to problem 50. All right, so I'm going to look for a GCF. There isn't one. So this is two terms. The only potential thing it can be is a difference of squares. Okay, so a difference of squares, which means is the first term a perfect square minus another perfect square. Well, the square root of 100 is 10, and any even exponent you can cut in half, and that tells you what it is, and the square root of 49 is 7. So now I know this factors into 10x plus 7 times 10x minus 7. And there's my answer. Neither one of these is a perfect square. I mean, it's difference of squares. Okay, 51, GCF. Nope. So there are two terms. So difference of squares. Well, yeah. I can write a to the fourth as a to the second to the fourth. The square root of 21 is 11. So this factors into a squared plus 11 times a squared minus 11. Now, even though these are squares, neither of these is a difference of squares. First of all, this one you can't do anything with because it's a sum. But 11 is not a perfect square, so again, you are done. Okay. All right, 10x squared plus 20x plus 1. Okay, GCF, I'm going to use all of them. There isn't one. So there are a couple of ways you can do this. Right off the bat, I recognize that 100 is a perfect square and 1 is a perfect square. So it may fit my pattern. Okay. So if I'm looking at the pattern, and again, I'm going to show you a different way to do it as well. You don't have to do it this way. So is it a perfect square trinomial? Which means, is it a squared plus 2ab plus b squared? Well, I can write this as 10x to the second plus 2 times 10x times 1 plus 1 to the second. And that fits my pattern. So this should be a plus b times a plus b. So this becomes 10x plus 1 times 10x plus 1, or 10x plus 1 squared. Now I will tell you, just because both of these are perfect squares does not necessarily mean that it's a perfect square trinomial. You have to test that middle term as well. Okay. All right, but say you don't like the pattern, that's okay. Or you can just split and group. So if I start out with 100x to the second plus 20x plus 1, I'm looking for two numbers whose product is 100, and those same two numbers, their sum is 20. Well, 10 times 10 equals 100. 10 plus 10 equals 20. If these numbers are the same, you know it's a perfect square. But still, it doesn't matter. So this becomes 10x plus 10x. Bring down my 100x squared and my 1. Now I'm split. I'm ready to group. So this gives me 10x times 10x plus 1 times 10x plus 1. My common binomial factor is 10x plus 1, and I'm left with 10x plus 1, or 10x plus 1 squared. Again, you do it either way you want. It doesn't make any difference. Okay. Now I'm going to have to write smaller on this one. 25a squared minus 40a plus 16. All right, GCF. No. Okay, so I want to check to see if it's a perfect square, because 25 is a perfect square, 16 is a perfect square. So is it a squared minus 2ab plus b squared? Okay. Well, this is 5a squared. This is 4 squared. So is my middle term 2 times 5a times 4? Well, it is. So I know this factors into 5a minus 4 times 5a minus 4, or 5a minus 4 squared. Now get a little more paper here. Say you don't see that. That is absolutely okay. All right, so let's try split and group. So that means if I'm starting out with 25a squared minus 40a plus 16, I'm looking for two numbers whose product is 400 and whose sum is negative 40. And those numbers are negative 20 and negative 20. So this becomes negative 20a minus 20a, 25a squared plus 16. Now when I'm grouping this one, I have to write it as negative. So my GCF here is 5a times 5a minus 4. GCF here is negative 4 times 5a minus 4. Notice these two are the same. That tells you it's a perfect square. But again, if whatever works for you is what works. So that becomes 5a minus 4 times 5a minus 4, or 5a minus 4 squared. Okay, I think we're done factoring. Oh my gosh. Well, we're kind of done factoring. Now we're going to go into solving. Okay, solve each equation. Remember the steps for this one. Okay, it has to be equal to 0. Then you factor. Set each factor equal to 0 and solve. And then, of course, number 4, you want to check. Okay. Make sure it's equal to 0 first. Don't be fooled if something is factored and it equals a number. Okay, so equal to 0, check. Factor is already factored. Okay. Set each factor equal to 0 and solve. So 5a equals 0, or 3a plus 2 equals 0. When I divide by 5, I get that a equals 0. Subtract 2, I get 3a equals negative 2. Divide by 3, and I get that a is negative 2/3. So those are my solutions. Now I'm going to check. Okay, so if I check a equals 0, I want to know 5 times 0 times 3 times 0 plus 2. Does that equal 0? Well, you've got 0. 5 times 0 is 0 times 2 equals 0. So that works. Now this one may be a pistol. Okay, so if I have 5 times negative 2/3 times 3 times negative 2/3 plus 2 equals 0. Well, that gives me negative 10/3 times negative 2 plus 2, which gives me negative 10/3 times 0, which equals 0. So this one also checks. Okay, if I have x minus 4 times x plus 3 equals 0, okay, it's equal to 0, it's factored, so let's set each factor equal to 0. So x minus 4 equals 0, or x plus 3 equals 0. So here x equals 4, or x equals negative 3. And now I'm going to check. So 4 minus 4 times 4 plus 3 equals 0. Well, that's 0 times 7 equals 0, so it checks. Check negative 3. Negative 3 minus 4 times negative 3 plus 3 equals 0. So that gives me negative 7 times 0 equals 0, so that also checks, so that's a solution. Now you can leave it just like that, but what we talked about before, you can also put it in set notation. So this would be negative 2/3 and 0, and this would be negative 3 and 4. And again, I always put it in numeric order. Okay, 56. It's equal to 0, but now I have to factor it. Okay, so there are 3 terms, and the leading coefficient is 1, so I'm looking for 2 numbers whose product is 6 and whose sum is negative 5, which are negative 2 and negative 3. So this factors into c minus 2 times c minus 3 equals 0. Now I have to solve each factor. So c minus 2 equals 0, or c minus 3 equals 0. Here this tells me that c is 2. Here this tells me that c is 3. And now I want to check. Okay, so I want to know if 2 squared minus 5 times 2 plus 6 is equal to 0. So that's 4 minus 10 plus 6 is equal to 0. Negative 6 plus 6 is equal to 0, so it checks. All right, let's check 3 squared minus 5 times 3 plus 6 and see if it's equal to 0. 9 minus 15 plus 6 equal to 0. Negative 6 plus 6 is 0, so this one checks also. So I have 2 and 3 as my solution set. Okay, x squared equals 81. It is not equal to 0. So I have to subtract 81 from both sides, and I get x squared minus 81 is equal to 0. Okay, so now when I factor it, there's no greatest common factor, but I do notice that both these numbers are perfect squares and that there's a minus sign. So this is a difference of squares. So this becomes x to the second minus 9 to the second, which factors into x plus 9 times x minus 9. So x plus 9 equals 0, x minus 9 equals 0, so x equals negative 9, x equals 9. Okay, so now I want to check. Alright, so for my check, I want to see if negative 9 squared equals 81. It does, so that checks. I want to know if 9 squared equals 81. It does, so this also checks. So my solutions are negative 9 and 9. Okay, I'm going to stop here and we'll do the application problems on the last video.